In this video, I will show you guys the three most important functional built-in functions in Python. These three functions, map, filter, and reduce, they're pretty much the most useful functions that you'll see ever. I'm not even joking. So let's get into how we can use these functions and why they're important. So if you remember from last episode, we did some work with lambdas and higher order functions. These are the previous two in the series. So I recommend you guys watch that before you continue here. But today I am going to show you what map, filter, and reduce does and why they are useful. So let's start with map first. So map is a function that pretty much does the mathematical counterpart of function mapping. Now, what do I mean by that? Well, let's define lists first. So our list is going to be called nums. And, let's just define some nums here. So 1, 2, 3, 4, 5, 6, 7, 8. There's, 8 elements in this. And then what we're going to do is how do we, let's say, apply something to everything in this list? Well, we could probably use a for loop. But remember, in functional programming, up here, one of the pillars of functional programming is no state storing. So we can't just use a for loop. That's outside of functional programming. And obviously, that is not what we're going to do. So we're going to use the map function. And I'll show you how this works. So to type the map function, you just type map, and then you can see Spider's already suggesting how we can do map. But I'll walk through that as well. So first, it'll take in a function. So whatever function you want to apply to your list. So we learned about lambda functions in the previous episode. So we can just use a lambda function. So lambda function, and then the parameter, I'll just call it num. And then let's say we can do num squared. And then, then we need the actual list we're applying to. And in this case, it's nums. So that is how you structure a map function. So the first parameter is a function or a lambda. I prefer to use lambda since they're easy and compact. But basically, this function will be applied to every single element in the list. So the list is nums. So let's try to print this result out to see our result squared. So let's just do it. And you can see something's wrong. What happened here? It says map object at this hexadecimal address. Well, that is because map, again, itself is a built-in Python object. So it isn't actually a list. So we need to basically see what happened to the map object. To do that, we'll just cast it to a list like usual. So we just wrap this whole map expression with list, and when we print it now, you can see we get all the squares. And that's, again, just applying this lambda function to that list right here. This can also work for other things as well, pretty much anything you want. So, for example, what we can do is we can do something like this. We can define, let's recall this to be list of names. And then what we're going to do is we can just define some names. So we have John, Dan, Alice, Bob. So you get the point. Now we can also apply a lambda function to strings as well. So we just type this to list of names, and we have to obviously, let's change our lambda function to reflect that. So we have name, individual name, and then we can do some manipulation with it. For example, we can say this equals name plus something at the end. For example, a period at the end. So this just concatenates a period to each name, and then it maps it to the whole list. So let's run this. You can see now we have a period at the end of each name. And again, that works for strings. So now you can probably see why map function is very useful. We don't need to use for loops anymore. And by the way, it's faster than for loop because it's implemented in C, which is way faster than native Python. So that is map. Pretty cool. And just so that you guys are also familiar, sometimes we don't really need to use map, but there's something very close to map, and that's list comprehension. So you guys probably have seen list comprehension before. But what we can do, let's go back to the nums here. Yeah, there we go. And then what we're going to do is we are going to do the same thing. So let's rerun this again, and you can see we get all the squares. So what we can do is we can replace this with a list comprehension. So what we can do is we can say num squared for num in nums. This essentially does the same thing. So let's run this. You can see it outputs the same thing. So this is kind of like the list comprehension way, but again, not really functional since we have a for loop in there. The map function doesn't really have a for loop, so that is technically more functional. So we can also look at a filter function. So just like how map function works, filter function is a bit more specific. It checks to make sure it basically filters the list. So what we can do something like this. We can again print filter, and then we can filter a lambda. Okay, we look at the nums again, and then we can filter. Let's say, what can we filter? Well, we can do num. Let's see if it's even, right? So everyone knows how to do even, right? Num divided by 2 remainder if it's equal to 0, right? And then what we can do is we can pass it in nums. So let's just run that. And you can see filter also is its own object. By the way, all 3 of these map, filter, reduce, they have their own objects. So be sure to cast that to a list. You can see now the list is actually updated. Only the even numbers appear now. The odd numbers are just gone because we filtered them. You can see, pretty cool. We can also do something else like, for example, we can do back to our names here. Actually, let's do some country names, right? We can have some countries. This is just a real life example of how you can use this. Let's say you're filtering a country. We have Germany, France, United Kingdom. This is just Europe countries. Sweden, Finland, Ireland. And we're kind of running out of room. We're kind of, let me just zoom out here. Hopefully you guys can see over here. And then we can filter for the countries that end with or just have land inside of them. So let's replace this with this lambda function with country, just a singular country. And then what we can do is, for example, land in country. So this is, trust me guys, this is super powerful. So we can pass in the countries here, and then when we run it, we can see, well, would you look at that? It just picked out Finland and Ireland. So you can probably do this with any other feature you like. And again, very powerful in terms of machine learning and doing data analysis. So we can further one more by combining map and filter. Yep, you heard that right. We can combine map and filter. So to do that, we can basically, let's take this filter chunk out, and then we're going to build a map function. So we're going to build a map, and this time we're going to map whatever country. So I'm just going to call it C, and then we're going to do C.upper. This basically takes whatever string is inside C, and then it basically makes it uppercase. So now we need something inside this map, second map function here, the parameter, and that's going to be where our filter comes in. So yes, I get it's pretty long. Usually, oh, not that. You want to split this into multiple lines, but I'll just showcase this. Let's see, maybe I'm missing a parentheses somewhere. Probably that's the reason why. Yep, there we go. So basically, we filter for a country with land, and then if it ends with land, then we capitalize them. So this could basically tell you a lot of stuff about your data, which is very, very cool. So that's pretty much map and filter. So very important in terms of functional programming. Now, The last one, reduce, is pretty weird. But it is a special use case, so we can actually see how we can use this as well. It's not in your standard Python built-ins. You have to import a library. But don't worry, this library is part of the standard Python library, so no need to do pip install. So we just do from functools import reduce. It lives in this functools library. And basically, what it does is it reduces a list down to one element from left to right. Let me just show you what that means. So, let's say we have a numbers list again, just like before. So we have nums equal to 1, 3, 5, 7, 7, 9. I can't type today. There we go. So these are just odd numbers. And let's say we want to sum, let's say we want to sum all of them together. So how will we do that? Well, we could do something like 1 plus 3. So let me just actually put a comment here. So 1 plus 3, and then we get 4, right? And then we take the result of that, and then we add it to 5. And then that equals 9. And then we take the result of that, we add it to the next element, 7, which equals 16. And then we take the result of that, add it to 9, which equals 25. And there we go. That's our answer, 25. But did you see how I did that? What I did is I summed them from left to right, taking each of these two numbers, the cumulative of them, and then we're piling it up all the way to the very end, again, from left to right. And that's exactly what reduce does. So let's actually print this out. So just like before, reduce also needs a, so we just do reduce, and then what's inside reduce? Let's do lambda. So it's going to take in two parameters, x and y. X is going to be your kind of like first little thing we want to add. Y is going to be your second little thing you want to add. So basically what we do is we do x comma y, and then we just do x plus y, just like that. And then what do we do now? Well, we pass in our nums, because that's what we're taking the value of. So let's run this, and boom, look at that, 25. So reduce, again, special use cases. You'll probably find some use cases once it pops up, but definitely pretty useful when you're trying to get like a singular result. I've used reduce for averaging. I've used it for, again, summing, multiplying. So just as a final thing, let's say we have this lambda function called add, right? Let me just, okay, I'll do this. So we just do add equals lambda. Well, let's just do a def statement. How about that? Because it's better. So we'll do def add, and then it's just return x plus y. So nothing too bad right now. But let's see what reduce actually does. Again, I kind of demonstrated this with this comment up here, but let's just to see what it really does. Here's what it does internally. So it does add, and then add, and then add, and then add. Inside the first add, we add 1 and 3. Okay, the result 1 and 3. Now let's add it to 5. Okay, now let's add it to 7. Okay. It's kind of getting, see, it's kind of getting confused with the parentheses there. So you gotta be careful with that. So let's run this print statement here. Yep, 25 down here. So that's what reduce does. But again, that is way too complicated and messy to look at. So we just do add. Yes, it does work with functions just like it does with the lambdas. We do this, and boom, both of them return 25. Pretty much exactly what we expected. So yeah, that is it for my little functional Python mini series. Hopefully you found these functions useful. Because look how much it sped up our workflow. But yeah, that is it for this series, little mini series. If you enjoyed this video, please leave a like and subscribe, and I'll see you in the next one.